In this video, we're going to be looking at the powers of binomials using Pascal's triangle. So I did 3 warm-up questions for you to try to illustrate the pattern that we will be seeing. So if you see x plus y squared, you're doing x plus y times x plus y. When you multiply that out using FOIL or double distribution, you end up with x squared plus 2xy plus y squared. When you do x plus y to the third, it's x plus y times x plus y times x plus y. And we just did the first product. So I substitute that in here and I have x squared plus 2xy plus y squared times x plus y. And now I'm going to distribute the x and I get this trinomial. I distribute the y and I get this trinomial and I have them stacked so I can nicely and easily add. I end up with x to the third plus 3x squared y plus 3xy squared plus y cubed. And you might be noticing some things. And then I'm going to do x plus y to the fourth. So I have the product x plus y times x plus y times x plus y times x plus y. And when I do the 3 binomials, I get this polynomial. So it's got 4 terms times x plus y, and now I'm going to distribute the x, I'm going to distribute the y, I stack them, and I add. And my conclusion is x to the fourth plus 4x to the third y plus 6 x squared y squared plus 4x y to the third plus y to the fourth. And there are a lot of patterns that are happening here. So let me kind of show you some of the things that we're looking at. First of all, the first term, so the x, it's going to have the exponent. So if 2 is n, the first term is x squared, or x to the n. Here it's x to the third. Here it's x to the fourth. The next term is 1 less. So I have x squared, x, and then this would be x to the 0. X to the third, x squared, x to the first, x to the 0. X to the fourth, x to the third, x to the second, x to the first, x to the 0. And then if you notice, it's reverse for the y. Y to the fourth, y to the third, y squared, y to the first, y to the 0. And it's the same thing with y. So x is got a decreasing exponent and y has an increasing exponent. So you start with y to the 0 and you're going to increase 1 each time. Another thing to notice is the sum of the exponents is always n. So if this is x squared y to the 0, 2 plus 0 is 2. 1 plus 1 is 2, and you have 0 plus y squared. Here you would have y to the x to the third times y to the 0. 3 plus 0 is 3. The 2 plus 1 is 3. 1 plus 2 is 3. Here's just the 3. Here's 4. 3 plus 1 is 4. 2 plus 2 is 4. 1 plus 3 is 4. And then y to the fourth is just 4. Okay, so we've talked about a lot of things except for the coefficient. And if you notice, you may or may not be familiar with Pascal's triangle. But the pattern here is you could even have zeros on the outside. I have seen it like that. But as you go through, you have 1 at the top, 1 plus 1 is 2. The outer parts of the pyramid stay at 1. And then when you go down to this row, if we're looking at row 3, 1 plus 2 is 3, 2 plus 1 is 3. When you do the next row, the fourth row, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. And that pattern continues all the way through the pyramid. So if you're looking here, if this is looking at row 2, if I'm looking at row 2, the first coefficient was the 1. The second coefficient, the second term's coefficient was 2. The last term's coefficient is 1. And then the next one, row 3, the coefficients 1, 3, 3, 1. And then row 4, 1, 4, 6, 4, 1. So there are a lot of really cool patterns that are happening here. So I'm going to flip over to page 2 of our notes packet. And you see the exponent, the Pascal's triangle, and then the binomial expansion. So I have already done out the first. We skipped a plus b to the 0. Anything to the 0 power is just 1. But you can kind of see nicely all of the other rows. So we're going to do the 6th row right now, just kind of using that pattern with Pascal's triangle. So the outer is always 1. 1 plus 5 is 6. If n is 6, it will be the second coefficient. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15, and then 5 plus 1 is 6, and then 1 is on the outer. And you always have that pattern where it'll be either odd or even, and the even row has one number in the middle. The odd rows has two of the same number in the middle, okay? And then the pattern will continue here. So I will have A, 1, and then times A to the 6, B to the 0, but I'm not going to write that in. And then my first coefficient will be the 6, so I'm going to have plus 6. And now A is going to go down a degree, so I have 6, A to the 5th, B to the 1st, and I can put a 1 there if I want, plus 15. And now A will be to the 4th, B will be squared, because the B coefficient will be going up by 1, the A coefficient will be going down by 1. So now the 4th term has got 20 as its coefficient, and then I'm going to have A to the 3rd, B to the 3rd, okay, and then plus 15, and I'm going to kind of run out of room, so I'm probably going to loop it a little bit. A is going down, so A squared, B to the 4th, and then I'm going to come over here and I'm going to say 6. A is going down by 1, so now I have 6A, and then B goes up by 1, so B to the 5th power, and then finally I'm not going to put the, well, I will put the 1, but you don't really need to. A to the 0, so you actually didn't need to put A to the 0, and then B to the 6th. And then you'll notice I have 1, 2, 3, 4, 5, 6, 7 terms. So I have one extra term than the row number, and that was true over here. So when x plus y is to the 2nd, there are 3 terms. If x plus y is to the 3rd, I get 4 terms. X plus y to the 4th, I get 5 terms. 1, 2, 3, 4, 5. And that's another pattern that you will see. Okay, so we're going to do 3 examples right now. We're going to find the first 3 terms of the expansion of 2x minus y to the 6th. So when I do this out, the 2x, I'm going to start way to the left because you really do need a lot of room to do these. So I have 2x to the power of 6. I'm doing the 6th row. You will have an oscillating pattern of positive versus negative because the y is negative. But right now, I'm just going to treat it the way I did over here so you could kind of see one way to say it. So this is plus 6, and now the 2x is going to have the power of 5. And the negative y, so I'm going to include that negative y, will have an exponent of 1. Okay, and now I'm going to have the 15, the 2x to the power of 4, the negative y squared, and now I'm going to have the 20, so plus 20, 2x to the power of 3, negative y to the power of 3, and now I'm going to have the 15, so plus 15, and now 2x to the power of 2, negative y to the power of 4. I'm really running out of room here. Plus 6 times 2x times negative y to the power of 5, and I didn't make it, and then plus negative y to the power of 6. Sorry, I guess I cut that off a little bit. Okay, and now we're going to do those all out. So 2 to the 6th is going to be 64. So I'm going to get 64x to the 6th plus, this is going to be 6 times 32x times negative y, okay, plus 15 times 16x to the 4th. Now that negative y is going to become y squared, positive y squared. All right, and then I'm going to get plus 20. 2 to the 3rd is 8, x to the 3rd. This is going to be a negative 1 times y to the 3rd. Let's see if I can try to get this to fit. Plus 15 times 4x squared, and then y to the 4th. Totally not making it, so this goes with that row. All right, and then plus 6 times 2x times negative y to the 5th. And then this one's just going to be plus y to the 6th. All right, so now I want to put all of that together as one final statement. So I'm going to be getting Oh, and this just asks for the first 3 rows, first 3 terms. So I'm doing a lot of extra. I'm not going to redo it, so that's fine. I just didn't read my instructions well enough. Love distant learning. All right, so 6 times 32, but times the negative will be negative 192. X to the 5th, forgot the 5 there, x to the 5th y. And now I'm going to do 15 times 16, and I'm going to get positive 240 x to the 4th y squared. And I certainly could be done with the question at this point. So this is the answer to this question, but I did all this extra. So at this point, I'm just going to keep going. This is going to be a negative. So I'm going to have negative 160 x to the 3rd, y to the 3rd. Here, I'm going to get positive 60 x squared, y to the 4th. I'm going to get negative 12 x, y to the 5th, and then plus y to the 6th. So this would be the rest of my expansion if you were asked to do the whole thing. So that was fun. Okay, number 2. The first 3 terms the first 3 terms of x plus y to the 17th are listed. So I have x to the 17th plus 17 x to the 16th y plus 136 x to the 15th y squared. Find the last 3 terms. So I really should have done a good job of reading my instructions for number 1, but I didn't. The difference between number 1 and number 2 is number 1 has a coefficient of 2 and a negative value here. So if you had wanted, you could have just said positive, negative, positive, negative, positive, negative, and done that repeating pattern. I just kept every term positive, and I kept the negative sign with the second term, and that works as a strategy as well. Number 2 is a pretty easy question because the coefficients here are both positive 1. So all of those other issues you don't need to worry about. And now I like to start these almost kind of reverse. So I know the first term is x to the 17th. That means the last term is y to the 17th. Only, and that's the only thing you're going to have because the coefficient here is going to be 1. The second to last term is going to have y to the 16th, and then the x term will be x to the 1st. This one is x to the 0. The coefficient will be 17. So because these are both 1. So I'm going to have 17 here, and this also tells me that 17 is going to be the coefficient because these did not have any additional coefficients. And then the third to last term will have the coefficient of 136. The x will be to a degree of second, so x squared, x to the 1st, x to the 0. Here I have y to the 17th, y to the 16th, and this will be y to the 15th. And that's all that I need to do there. So that was a pretty straightforward question, especially if you read the instructions. All right, and then the last one is find the first 3 terms. The first 3 terms of f minus g to the 15th are f to the 15th minus 15 f to the 14th g plus 105 f to the 13th g squared. Find the last 3 terms. So it's very similar to the one that we just did, except that this is going to be negative. So just pay attention to that. So your last term will be the negative g to the 15th power. And then I could put a plus there. And then the second to last term is the negative g to the 14th power times the f. The coefficient will be the 15. And then the third to last term will have that negative g to the 13th power. Okay, and then the f will be squared. And then the coefficient here is going to be the 105. So now if you look, this guy, this term, this negative g has got an odd exponent. So that's going to make this negative 105 f squared g to the 13th. This negative g has an even exponent. So that's not going to affect the positive or negative, or the positive here, so it's just going to stay positive. So I have positive 15f g to the 14th, and then because this negative g has an odd exponent, the last term will be negative g to the 15th. And any time that the exponent is odd. So this one had an even exponent, number 1, and this term was negative, that would be positive. But if that was negative, if this is an odd, so if it's even and this term is negative, it'll be positive. If this is odd and this term is negative, then the last term is negative. And that's because of that oscillating pattern. All right, thank you for watching. I hope this helped.